Hello again, and welcome to our series on the wonders of astronomy. This series is celebrating the 400th anniversary of Galileo first turning a telescope towards the heavens and starting the scientific investigations of astronomy. So we're inviting you to participate in this, and at the end I'll show you some websites you can go to possibly look up a star party or a meeting or something of that sort. So let's begin looking at galaxies. Now, you might recall when we talked about the planets and so on, we started at the Sun and we went all the way out to the Kuiper Belt. Now, in this particular program, we're going to go well beyond that. We're actually going to go out into the universe and see what's out there. Now, we can begin by looking at this galaxy. This is a typical galaxy. In fact, it's our closest one to us. This is called the Andromeda Galaxy. But let's for a moment pretend it is our own galaxy. It has a very bright center and then a disk of clouds. Now that disk looks very much just like a paper plate. It's very thin, disc-shaped, and contains probably 200 to 400 billion stars. Now we're located about halfway out here in the suburbs, about halfway between the center and the outside edge. Once again, we're going to use that astronomical tape measure of light years. So I wanted to stop again and talk to you about what a light year is. Now, if you took a flashlight and shined it up into the night sky, the light beam would travel out at a speed of 186,000 miles per second. Now that's a pretty high speed, but we measure how long it takes light to travel 1 year at that speed, and the distance is 5.8 trillion miles. That's 1,000 billion is a trillion, so it's quite a tremendous distance. We're going to be looking in this region here from 10 to 100,000 light years for a while as we look into our own galaxy, and then we're going to go all the way out to look billions of light years away. Now here's artist representation of our galaxy. Now obviously we can't get a picture of our galaxy because we can't move out that far fast enough to actually get one. But the Sun is located here. As I said before, it's about halfway out. You'll notice that our galaxy has a slight bar to it in the middle. Then it has two major arms. This arm here, it's called the Perseus arm, which goes on out. And then another one called the Scutum Centrum arm right here. And it has some smaller arms as well. And as you see, we're located here in a small spur called the Orion Spur off that Perseus arm. Now, if we were able to get outside of our galaxy and take a look at it from the side, it would look something like this. We'd see that it's 100,000 light years in diameter. It would have a central bulge, and that bulge is about 10,000 light years. The disk itself is about 2,000 light years thick, or about 2% of the diameter. However, most of the major action is in this very small band. I call it small, but it's 400 light years thick. This is where all the star formation and most of the gas resides, and where we reside in our own star. As I said before, we're out here halfway, about 26,000 light years away. The Sun orbits the center of the galaxy every 250 million years. So you won't be going around once in your lifetime. And it orbits at a speed of 484,000 miles per hour. So if anybody asks you where you were an hour ago, you can tell them you were 484,000 miles back that way. In the center of the galaxy is a supermassive black hole. Astronomers have recently found that every galaxy seems to have one of these giant black holes in it. And the one in the center of our galaxy is 3.7 million times the mass of the Sun. Now, until Edwin Hubble came along, astronomers looked at the Milky Way and thought that that was the universe. And at 100,000 light years across, it would satisfy me to be the universe. But Hubble and some other astronomers thought there might be more to it than just that. So he began a scientific investigation. What Hubble did is looked at that Andromeda Galaxy, that one that's closest to us, and he used a new telescope at the time. He did these observations back in 1924, and he used the biggest telescope then, which was the 100-inch telescope at Mount Wilson. Today that's considered an antique, but at the time it was state-of-the-art, and he was able to look at a specific type of star called a Cepheid variable. And that star then told him exactly how far this disk of stars was. At the time, astronomers knew that the Milky Way galaxy was 100,000 light years in diameter. Hubble showed that this one was more than 1 million light years away. In fact, it's 2.3 million. His measures weren't too good. He knew it was a little over 1 million, but today we know for sure that it's 2.3 million light years away. So he opened up the universe to us. Suddenly we realized that these swirls in the sky, originally we thought they were just swirls of gas within the Milky Way. Now we know that there were separate star systems all to their own. And that means there must be thousands more. And in fact, there were not thousands or millions, but billions more. Now, another thing Hubble did, besides expanding our view of the universe, he started to classify the types of galaxies that he saw out there. Now, first of all, we have these elliptical galaxies. These are simply balls of stars. Some are almost round like the E0, and then some are stretched out, elongated a bit like the E7. But they're pretty much featureless, as you'll see in some of the slides coming up. Then there's the spirals, the ones we know and love so much. And they start out here with no structure and get more and more structure as we go out. Then there's another type of galaxy that we call the barred spiral. This type has a bar in the center and then arms attached to it. And as you saw in the diagram of the Milky Way, we do have a very small bar in the center of ours. So the Milky Way is halfway between a typical spiral and a barred spiral. Now here's an example of one of those barred spirals. Now if you had told me that such a thing existed, I wouldn't have believed it till I see this photograph. This is from the Hubble Space Telescope. You can see here a prominent bar going across and then these two arms. And this is a particular galaxy that's 70 million light years away. That means that the light that we're seeing right now left that galaxy 70 million years ago when dinosaurs were still on the Earth. And it's just now reaching us. Now here's a typical elliptical galaxy. As I said, they're pretty featureless. They're simply just a ball of stars, tend to be old, rather dim stars. Not very exciting at all. What you see here, these are actually two galaxies in the background. We're actually looking through that, the edge of that particular galaxy. So these are pretty boring to me. Now, the thing that we normally think of as a galaxy when we do mention galaxies are these beautiful spiral galaxies. And here we see two of them that are interacting with one another. This is in the Virgo Cluster. They're 90 million light years away. I'm sure if there's some intelligent civilization halfway between these two, they're arguing which galaxy they belong to, because they actually are, as you see, beginning to share stars in the central region. Now, I once thought that these spirals were all there was for galaxies, and certainly we're the major number of galaxies, but as you can see, they're only 25% of the galaxies. The vast majority are these elliptical galaxies. 60% of the galaxies are these boring elliptical ones. Only 25% are the spirals, and then irregulars count for about 15%. Now, the thing that makes the spiral so interesting is that they have a lot of young stars as well as old stars. That's because they have a large gas content. The gas content of a spiral is typically between 5 to 15%. It means it has enough gas and dust to create new stars. So we have population 1, young stars, and population 2, old stars. Those boring ellipticals only have population 2 stars, very old, dull stars, and irregulars have a little bit of both. One thing that's unusual about the spirals is they have a high amount of what we call angular momentum. In other words, they're rotating very rapidly compared to the elliptical galaxy or the irregulars. And we think it's that high spin rate that flattens them out into a disk. And these bottom numbers here are simply the ratio of the size of these galaxies to our Milky Way. So you can see that these ellipticals can get pretty large, 5 times the size of the Milky Way galaxy. Spirals tend not to go much above 2 times the size of the Milky Way galaxy, and so we're pretty much an average galaxy. And then these irregular things are very small. They typically are about 1/10 the size of the Milky Way galaxy. Now, interesting thing, I mentioned that these spiral galaxies rotate, and they rotate, the stars rotate in that disk around the center. Originally, astronomers thought they would orbit the center just like planets orbit the sun. If you recall that program we had on the solar system, we saw that the further out we go in the solar system, the slower the speed at which the planets rotate. Mercury was up there at 107,000 miles an hour. By the time we got way out to Neptune, it was 1/10 that amount. So this is what we would normally expect if something is rotating around a very large, massive body. But when they looked at galaxies, this is what they found. It's completely different than this curve here. It seems to be a rigid portion here, and then essentially a constant speed all the way out. And at the speed at which these stars are going out here at the edge, they should fly off into space, but they don't. So something is happening to make this curve look this way. And that unusual ingredient is called dark matter. And it seems to form a halo around the entire galaxy. We don't know what it is. We have no idea what that is. There's a Nobel Prize in physics for you, no doubt, if you can figure out what dark matter is. Now, when we look at it, at a picture such as this of another galaxy, when we see a very high gas and dust content, this is not dark matter. As I said, there's no way we can determine exactly what dark matter is. It seems to form that spherical halo. We know that because the galaxy is holding together. There must be some gravitational glue holding the galaxy together, but we don't know exactly what it is because it doesn't emit any form of electromagnetic radiation. There's no light, there's no radio waves, there's nothing that we can detect. But we know it has to be there, otherwise the galaxy would just dissipate. Now, one thing we can do with computers, we can at least simulate what dark matter might look like. This is a picture of a cluster of galaxies. These are not stars. Every one of these spots is an entire galaxy unto itself. This is a particular cluster of galaxies located about 4.5 billion light years away. With computers, the scientists and astronomers were able to determine what the dark matter might look like. And what they determined is that what we can see, that matter that we can see there in those galaxies, is only 10% of what's there. 90% of it has to be dark matter. So there's a lot of it out there. Around our own galaxy is probably 3 or 4 times what we can see in terms of stars and so on. So there's a lot of dark matter out there, but we just don't know what it is. Now let's take a journey into the center of our galaxy. into that big glowing bulge that we saw in the other picture. When we look in the summer night sky at the constellation Sagittarius, which many people call a teapot. It looks a lot like a teapot to us. We are looking right into the center of the galaxy. But the problem, when you look at this visually, this is what you see, just a bunch of dust, and we can't actually look into the center with optical. So we have to use something else, and what we use is infrared. With infrared detectors on the telescope, we can actually look into the very center. And these arrows show what we know is the center, because that center has a supermassive black hole in it. We can't see the black hole, of course, because it's black. A black hole is basically a body that's so dense that nothing can escape, not even light can escape out of it. So that very dense body is there, and we can see these stars orbiting around that point in space. So we know that's where the supermassive black hole must be. And notice this, we're getting in pretty close here. This is 1 light year across. Now, oftentimes those supermassive black holes begin to feed on material around them. The black hole in the middle of our galaxy is not. It's dormant. It's quiet. But when material comes close to the black hole and gets sucked into it, it starts to whirl that around rapidly and heat it up to tremendous temperatures, millions of degrees, and often that will shoot a jet of particles out into space. And this is what we see here. This is an active galaxy that has a black hole that's now feeding, and it's shooting that energy and those particles out into space. And this arm here is 13,000 light years long. Now we can see that because we're combining X-ray, radio, and optical measurements and putting them together into one composite image, and that's what this is here. This then allows us to see this jet of energy coming out of it. Now let's go around our neighborhood. Here's the Milky Way galaxy in the middle, and if we look around our neighborhood, we see a bunch of small irregular galaxies. These are just bits and pieces of galaxies. They might have been left over from the formation of galaxies originally, or they could have been parts that were thrown off galaxies as they collided. But we see quite a large number of these small little galaxies, and we actually have 1 or 2 that are actually now being absorbed into the Milky Way. So the Milky Way is continuing to grow as these bits and pieces come into the center and become part of the disk itself. Now here's an example of one of those. This is called the Dwarf irregular galaxy. The name of it is Leo 1. You can see it's relatively small. You remember the Milky Way galaxy was a full 100,000 light years wide, where this is only 1,000 light years wide. And eventually this may get absorbed into the Milky Way itself. Here's another one. This is the Large Magellanic Cloud. If you ever go to the southern hemisphere in South America or Australia or something like that, you'll be able to look up and see the large and small Magellanic Cloud. Both of those are some of these irregular satellite galaxies that belong to the Milky Way and orbit around the Milky Way itself. So it's very close to us. It's only 180,000 light years away. So with our telescopes, we can dive into this and we can see it in a lot of detail and study it, and that's very interesting. So what does our neighborhood look like? Well, as I said, we have these satellite galaxies that are floating around. We have the Milky Way itself. We have the slightly larger Andromeda Galaxy. Then we have another spiral galaxy called M33. These 3 major galaxies plus all these small irregular galaxies, and you can see here the Andromeda Galaxy has 2 of those small irregulars around it. This is our neighborhood. This is where we belong in space. Now, it's interesting that M33 and the Andromeda Galaxy are tending to come together, and they'll merge with our galaxy. So there's going to be a train wreck ahead, but that collision will probably take place about 5 billion years from now. So I wouldn't worry about it. If you have a party scheduled for then, I'd move it up earlier. But other than that, don't worry about this collision that will take place. The early universe, we think, was pretty chaotic. In fact, we have measurements now to show it. There are lots of scraps around, and it was these scraps that seemed to come together to form some galaxies. Here we have a picture from the Hubble Space Telescope. This is looking at galaxies that are 10.6 billion light years away. So it took the light from these galaxies 10.6 billion years to reach us. And you can see this just seems to be a bunch of scraps that are coming together to form a larger galaxy. This picture is very interesting. This is called the Hubble Ultra Deep Field image. This was an image taken by the Hubble over a period of 2 weeks with an exposure of over 1 million seconds, 1 million seconds of exposure. These little circles that you see represent those scraps that we saw in the other picture. These are the farthest things we can see away from us. Just about everything you see in this picture is a galaxy. There are a few stars, these things with spikes on them, one here, one up here. Those are stars, but other than that, everything else is a galaxy. They say in the original image there's over 10,000 galaxies. And they pointed the Hubble at a point in space that they didn't think there was much at all, just to see what was out there. And so everywhere we look, there's galaxies like this. Just looking at the nearby galaxies, the ones that we can easily see with a ground-based telescope, somebody went to the trouble of plotting them all, and this is what it looks like. There's only 2 million, so this is a very small amount of the galaxies that are out there, just within range of our telescopes. So you can see there are actually more galaxies in the universe than there are stars in the Milky Way itself. When we get out there and look at these galaxy clusters, we see that often they form a string. I've put a dashed line here to kind of show you that string of galaxies. This is very typical. Galaxies are social animals. They tend to cluster together. This particular chain is part of the Virgo Cluster, 70 million light years away. And incidentally, our local group is headed in that direction. Of course, by the time we get there, everything else will have moved away also. But in the Virgo Cluster, there are over 2,000 galaxies. In some of these clusters that we look at, there are up to 10,000 galaxies. It's amazing, the number. Now, if we were able to go way out into space, and this is just a computer simulation, but if we were able to get far enough out into space, what we would see is a web like this. This is almost like a sponge. And the galaxies seem to cluster around these voids in space where there's absolutely nothing. And so it kind of looks like almost spaghetti or a sponge or something of that sort. And the galaxies are all in there, and there are many large voids. Now, we're looking at quite an enormous scale here. Between these two arrows, we're talking about 100 million light years. So this is something that we can talk about, but we can't really visualize or imagine. Now, often, if things are that crowded out there, you can imagine there must be some train wrecks, and there are a lot of train wrecks. Galaxies are constantly slamming into one another or coming together and forming larger galaxies. Sometimes when a smaller galaxy goes through a large one, it will strip away some of the stars, and in this case, as you can see, something went through this galaxy. It's no longer there, but it left this big ring of stars, and with a lot of active star formation taking place in it, and it left the core, but there are very few stars here in the center. Here's another one. This is called Hoag's object. Again, a ring galaxy where something went through the center of it and robbed a lot of stars and left this donut shaped with the core in the middle. Here's one of my favorite objects to look at with my telescope. This is called M51, or the Whirlpool Galaxy. Now here we see a beautiful large spiral galaxy, and then we see the smaller satellite galaxy, and it seems to be feeding stars into the bigger galaxy. And the fact that this galaxy is here is creating a lot of star formation. All this red and pink that you see are active areas of star formation in this big galaxy. So we find this going on all the time, and as you look around space, there's quite a few interactions of that type. So it's very common. Now let's stop talking all this scientific stuff and just simply observe and look at some of the beauty of these galaxies. Now as we look at these, you'll see them somewhat change color. That's simply because the pictures are taken with different filters and color coded a little differently. This probably represents pretty close to the true color of a galaxy. These of course are taken with long time exposures with very large telescopes, so if you ever look at one of these in a smaller telescope, you won't see any of this beauty. They're only revealed with long time exposures. Here's another couple. This is some of my favorites. Again, these are called M81 and M82. M81 here, M82 over here. 82, as you can see, has a lot of activity there. It is an active galaxy. These are located just above the Dipper part of the Big Dipper. And here are a couple others, a small group of galaxies. You can see we're looking at this one almost edge on here. And another one with a lot of star formation. These bright areas tend to indicate where stars are being born. Here we see two very much in the process of merging together. We can still detect a small center to this galaxy and then the larger center here. So eventually this will probably come into this galaxy and join it. And here's a cluster. This is called the Perseus Cluster. Another one of these, almost everything you see in this picture is a galaxy. It's not a star, it's a galaxy. Here's one of my favorites, called the Tadpole. You can see as this train wreck is taking place here in the major galaxy, it's throwing out this big tail of stars. Here's a closer view of an active galaxy. You can see here this has a lot of gas content, so it's glowing with a lot of red, a lot of star formation. And there's a lot of activity in the center. That black hole is being fed material and spinning that up to a very high velocity, high temperature. And here's another beautiful one. This is another picture, closer picture of M82 that we saw before. And you can see all the material being ejected from the center of that galaxy. Here's another one that apparently seemed to get a sideways glance collision. Very unusual shape to it. This one is often called the cosmic bird. It does look like a bird or an insect, but actually it's three galaxies that are coming together right now to form one large galaxy. And here's another beautiful galaxy. This one is NGC 2903. Many of the objects out in space are designated NGC, which stands for New General Catalog. It was new in 1850 anyway. Here's another beautiful spiral galaxy. You can see all those arms going around. So that completes our tour of the galaxies. The next presentation will be on extraterrestrial life. I think you'll really enjoy that. I'm not going to be talking so much about UFOs, but I'm going to be talking about the scientific reasons that we think life is out there. And I personally believe there's enough evidence that life definitely does exist out there in the cosmos. So I think you'll really enjoy this program.